So good morning. So in the last class, we have essentially looked at module 1, where we have got an introduction to our course. And importantly, what do you mean by safety aspects that are going into vehicle crashworthiness improvement? So the module title, Introduction to Safety and Crashworthiness, is what we have done in the last week, and it is finished. It is an introductory module, so it is going to give you an overall idea, and that lecture notes, whatever is there and we have gone through, is sufficient for that module. And we are going to start with the second module today, which is crashworthiness. Or it is crash testing. The title of module 2 is crash testing. And I'm going to have today's lecture, importantly, frontal barrier crash test, full frontal barrier crash test, how it is being executed, more details on that, which is basically a recommendation by Motor Vehicle Safety Standard 208 standard, and which has been administered by National Highway Traffic Administration, Safety Administration, right? So that's what today's class we are going to see in detail. When you look at, there are different crash tests that are conducted. What are those different crash tests? What standards are followed? What type of instrumentation that go in? How the test environment is prepared? How the vehicles are rated? Star rating is what has been an important rating. So what do you mean by the star rating? This is all something that today we are going to look at in the morning lecture. And in the afternoon, we will go ahead with the continuing again, looking at another type of crash test, maybe that is offset full frontal barrier and side impact test. So in today's two periods, you'll be having a good idea and understanding of what are the standards, how these tests are conducted, and so on, right? That's what is the briefing of today's two lectures activity, one in the morning, one in the afternoon. So let me share my screen for today's class. So hope you are able to see this, and obviously what you are seeing is what we have done in the last class. I just quickly browse through the slides so that we will recapitulate and on track with to continue with the last hour's lecture. All right. So we were started with the motor vehicle safety era. So we have divided that into 3 eras, and we were able to comprehend what was that in individual era as far as the development of vehicle safety in the field of vehicle crashworthiness has gone into. So the third period is very important period because of that legislative act and government regulations have been brought in, and federal motor vehicle safety standards have been administered through National Highway Traffic Safety Administration. So this is what we begin with in the last class, and we were looking at the development in individual periods, and we were also looking at the type of designs the vehicle body structure for different load requirement, exterior, interior requirements, and so on. And then we were looking at in detail how these materials of automotive materials have been evolved along these years. And what do you mean? How do you define the terminology crashworthiness? It started in the aerospace industry, first definition, and then it is also been defined for an automotive industry and restraint systems and its importance, all that we have seen. And what are crashworthiness goals and its requirements? How can we achieve this crashworthiness? And what are different crashworthiness tests? Just we have looked at that types. We got an initial idea of crashworthiness tests. So they can be varying from laboratory component level test till a full frontal barrier test, right? So you also see that there are also called sled tests, which are again carrier vehicle into vehicle to crash and so on. So the significance of these tests all are in detail is what we are going to study in the second module, and we are going to start with that today. And we also have looked at the idea of what is this full-scale barrier test. So today's lecture is fully on this full-scale barrier test. And this test is conducted as per FMVSS 208 and new car assessment program. So these are the test authorities, the test programs is what we are going to use or going to educate ourselves to understand full-scale barrier test today. And of course, these pictures are given as an idea of looking at and admiring and wondering how these tests are conducted, see such a wonderful laboratory facilities and so on, to have an idea that we have seen. So this all we are going to look at in detail is what is our second module. And then we have also looked at this Crashworthiness model requirement. These models are because of cost effectiveness. Every OEMs, of course, they do spend money for real crash tests, but for the product development, they also have to extract the advent of modern computers and computing facilities. So in such aspects, if you look at the Crashworthiness models are another field of evaluation of crashworthiness of vehicle through simulation studies. So what are those requirements is what we have looked at and ended our last our class. And these aspects of overview or an idea is what is that is being expected in module 1 in a comprehensive understanding. So we have finished with module 1 and today we are going to get into module 2 to look at crash testings in detail, right? So let me begin with today's lecture, number 4, crash testing. So an actual crash test, if you look at the National Highway Traffic Safety Administration conduct 2 types of crash tests as part of the new car assessment program. What are the 2 types of crash tests? One is 35 miles per hour frontal impact. So in this test, the vehicle runs straight into a solid concrete barrier. This is equivalent to a car moving at 35 miles per hour, hitting another car of comparable weight moving at same speed. And if you look at another crash test, is side impact test. That's also called 35 miles per hour side impact test. So why these specific speeds of 35 miles per hour is an average vehicle speeds that are accounted. So with these speeds, if vehicle is ridden, the worthiness would be realized in reality. The safety system can be supporting. Of course, if high speeds and frontal impacts are the real accident scenarios, if you see, it may not be possible. Still, there are restraint system to get in that speed, because the restraints deployment or the act of passive restraint systems would be quick enough within these speeds. If we go with the higher speeds of vehicle, then still we need to work on improvement of this passive restraint system, especially airbags, right? So these are the 2 tests. So the second test we will see in the afternoon class, that is 35 miles per hour side impact test. So it is basically 3015 pound sled. So the sled is another vehicle. It is not a real car. It is that requirement like barrier vehicle with the deformable bumper runs into side of the test vehicle. So why this test is conducted? It is to simulate the scenario of this. The sled's tires are angled. It's not straight, it's angled. Though the vehicle appears to be straight right angle to the test vehicle, it is angled. The test simulates a car that is crossing an intersection being side swept by the car running a red light. So in the barrier vehicle, deformable bumper vehicle is sent with an angle tires so that it will sweep the side of the test vehicle and crush it during the crash, side impact crash. So the sled actually moves with 38.5 miles per hour, which is greater than 35 miles per hour. But when you do that math, because it's an angle, so if you take a component at right angle to the vehicle intersection, it would be equivalent to 35 miles per hour side impact because of the way the wheels on the sled are angled. So this is what is the two important tests that are being carried out by new car assessment program administered by NHTSA. So we will see in today's class this first test, frontal impact test in detail. So first in hand, any crash test to conduct, the crash test dummies are prepared. So the test dummies are used to simulate human beings during a crash while collecting data that would not be possible to collect from a human occupant. See, so important. So we can't take a risk of volunteers to sit in a crash test and taking their life. So the test dummies are used in place of humans. What was an advantage of test dummies? They could carry the complete instrumentation and able to collect the data which a human occupant may not be able to do so. All frontal crash tests are conducted using the same type dummy. That's very important. Then only you'll get a consistency. Right? What is that common dummy used is hybrid 3 dummy. So we have one module in our course only to look at the family of dummies, what are their specification, which test, what dummies to be preferred, and so on. All we will go through that module at that time. Right? So this hybrid 3 dummy is the commonly used dummy, and that has to be used repeatedly. This guarantee a consistent result. A dummy is built from materials that mimic the physiology of a human body. So the material of the dummy also is important, so that we will bring in physiology of a human body. So that is all something an aspect that go into development of dummies, dummy development, right? So the early dummy would not have behaved exactly as a human body, but today's latest world-class dummy would almost able to resemble a human, is what is that is called a mimic of physiology of human body. For example, it has a spine made from alternating layers of metal disc and rubber pads. So rubber cannot be treated as a tissue. Metal disc cannot be a real bone because they are different for different humans. But you see that these metal disc embedded with rubber pads would almost resemble the real human occupant spinal. So this is what is the latest development in dummy, and such dummies are used. The dummies come in different sizes and they are referred to by percentile and gender. So if you say a dummy, that would be called like that. 50th percentile male dummy. What does that represent? Represent a median sized male. Median sized male means it is going to be one has got two sides, right? Means it will have one range below, one range upper range. So it is bigger than half the male population and smaller than the other half. That's what is called a median sized male. So 50% median sized male dummy is what is the popular dummy. So this is a dummy most commonly used in crash testing, and that weighs 75 kgs and the height of the dummy is 5 feet and 10 inches tall. So this crash test dummies are ready to replace a driver position, to accommodate in a driver position. And what are dummy sensors? So the dummy is full of sensors mounted in it or embedded in it. So there are three important sensors. Those are accelerometers, load sensors, and motion sensors. So the crash test dummies has accelerometers all over it. Inside the dummy's head, there is an accelerometer that measures the acceleration in all three directions. What are those? Fore aft, up down, left right, and so on. So there are also accelerometers in the chest, pelvis, legs, feet, and other parts of the body. So these accelerometers would give you the real-time acceleration history that are being experienced by dummy during the full frontal barrier crash test. Or for other matter, if these dummies are used in other types of tests, how that human physiology or the human response for this very complex severe test severe accident scenarios. Another important sensor is load sensor. So inside the dummy are the load sensors that measures the amount of force on different body parts during the crash. And motion sensors. These sensors are used in the dummy's chest. In the chest, the motion sensor typically placed, and they measure how much the chest deflects during a crash. So if we have to witness the measure of these sensors, that could be seen here on the right. There are three graphs are plotted for the sample of these three sensors measurement. The graph at the top shows the acceleration of a driver's head during 35 miles per hour frontal crash. So you can notice that here it is not a steady value. It is not one value. See, you can see this fluctuation here. You can see this fluctuation here, right? So there is a peak at this particular time. If you look at this entire horizontal time scale, it is 120 milliseconds. It is 120 milliseconds. So it's not even a second. So the entire crash event happens in a fraction of second, 120 milliseconds duration. So in this few millisecond duration, you see sudden peak in acceleration and then falls and it goes like that. So it is not a constant acceleration value that you get. Like in the case of ride RMS acceleration measurement, you see there are particular speed, there will be a particular value and so on in vehicle dynamics that we have looked at for a steady state motion. But during accident scenario, collision scenario, the levels of accelerations are tremendous. The accelerometers which are used for crash tests are not just normal crash tests used for normal accelerometers used for measuring vehicle response during steady motion or normal operating conditions. So the sensitivities are too much. So if we use 50 G's accelerometers in case of a normal testing condition, here you see some 2000 G's to 3000 G's acceleration sensitivity are used. So such kind of sensors are mounted in the head, and that gives you this. So this graph on the top, this graph is a graph that gives the acceleration of a driver's head, right? So this reflects the way the head slows down during a crash, with the highest values coming when the head strikes the hard objects or the airbag. So if you see this few seconds, that is the beginning of the crash, just hitting the barrier, and then it suddenly shoots up this acceleration, measured the head sensor of the dummy, that shows there is a hit with the airbag or the steering column and so on, if airbag is not deployed. So this is that thing. Then again, no, it goes and then it comes. So this is how you get your acceleration data that would help you to map with what are the other things. So you see these graphs I have put it one below the other to exactly see how the force measured and the movement sensor in the chest all are capturing the data of this. So these data are taken from NHTSA. Right, so you see this middle graph, the force in Newton measures by load sensor in the driver's femur. So that's thigh bone. So what does the thigh bone of a driver experiences? What forces that experiences during the crash? The maximum load in the bone can be used to determine the probability of its breaking. Or you should have that. You should have the system that the knee hitting on the panel or in the firewall should be prevented. Is what is that this data would be quite useful. The movement sensor or the motion sensor called are used in dummy's chest. They measure how much the chest deflects during the crash. Graph at the bottom shows the driver's chest deflection during the crash. In this particular crash data, the test, the driver chest is compressed about 2 inches. This injury would be painful, but probably not a fatal. So 2-inch crash is not making the person to die, but it is a severe injury. So we need to also understand how do you measure these injuries. All that also we will be seeing in today's class, right? So these are the 3 important types of sensors that are employed in the dummy, and those are called dummy sensors: accelerometer, load sensor and the motion sensor, right? And then a typical crash setup, if you see, first in hand is crash test paint. So what is this crash test paint? Before the crash test, dummies are painted and placed in the vehicle. So you can see here on my right, this dummy is being painted. So different colors of paints are applied to the parts of dummies bodies most likely to hit during the crash. So painting them and conducting the crash test would give an idea of what are the contact points of human body parts with the vehicle during collision. The dummy's knee, face and areas of skull are each painted with the different colors that you can see in this. Right, face with the blue color, and you can see the knees are with the brown or red here, and then you see the head with the yellow color, and then again the skull rear head is with the red color and so on. So the different colors painting been applied onto the dummies. In the photo, one can see that the blue paint from the dummy's face is smeared during the airbag, and that is left knee painted in red hits the steering column. So that you could see here. So this down picture, you see this front panel of the board. So you could see here there is a red marking, and you see here there is blue marking. And this picture there are paint on the airbags and so on. So this shows how severe the heat. If this marking are not there, that means there is no heat of knee on that. So this is an idea of by intensity of this paint on this wall, researchers or the test engineer, crash test engineer will be able to assess. So that is what is the purpose of this crash test paint. If the researchers note a particularly large acceleration in the data from the accelerometers in the dummy's driver's head, the paint marks in the car will indicate what part of the body hit what part of the vehicle inside the cabin. This information helps researchers to develop improvements to prevent that type of injury in future crashes. So that is how the crash test with this dummy painting would be quite useful. So the front passenger side dummy knees hit the dashboard during the crash. Also note that nothing from the engine component penetrated the cabin. So you could see here after the crash event, there is no penetration of engine. That's very clear. The engine on the most cars is mounted so that in a crash, it is forced backward and downward. So it won't come inside the cabin. Cabin cubicle would be preserved, but the movement of your engine is backward downwards, so that you have your cabin integrity maintained. So this is what in first hand, the first step and the painting significance of dummies, and you would realize during the test. A typical test vehicle setup, this photo is being shown. So this van is ready to crash on the barrier, right? So what does that mean? It is not that you should have your vehicle at very far away and that has started hit. Maybe it is the picture is just before it hits the barrier. So the distance from the barrier would be calculated, and that would be guided by an elastic pull. So the vehicle will be pulled towards the concrete rigid barrier, right? So let's look at what are the details here again in this test setup. So you can see on this side the picture far away from the barrier before the test start and after the test over, how this vehicle crashed. So the vehicle crushed here, the front portion is crumbled completely, but you see the cabin and the rest of the vehicle is integrated. Nothing happened during the frontal collision. So let's go into this detail. So the dummies have been placed in the car and are in position. That's what is set go for the test. All the instrumentation of the car and dummies have been hooked up unchecked. So there will be pre-check before executing this test. All sensors functioning or correcting and making them ready. And also important, this ballast is added to the car so that the crash test vehicle weight and its distribution of that weight is equal to that of fully loaded vehicle. So the test is conducted to have simulate a fully loaded vehicle. A speed sensor has been mounted to the car and positioned so that it will pass through the pickup just as the car hits the barrier. There are 15 high-speed cameras, including several under the car pointing upward, and they shoot around 1,000 frames per second. See, look at the speed of the camera. 1,000 frames per second means you would see that every 1,000th second what's happening, what is the change in the deformation of your vehicle. So this 15 high-speed cameras are data are very important. So we will see them in detail. What is this image analysis? So how these images are looked at and they are used in further vehicle safety measures. Right, so these are the cameras specification, and then the car is backed away from the barrier. So this is what you have to see. It's backed away from the barrier and prepared to crash. A pulley mounted in a track pulls the car down the runway. So it has been pulled. It is not driven. It has been, the vehicle is just been pulled towards the barrier. The car hits the barrier at 35 miles per hour. So the pull speed, the speed has to be calculated. The car from zero, that is station vehicle, has been pulled. So as it hits the barrier, it should have a speed of 35 miles per hour. So there involves a calculation, just it's a simple calculation, what deceleration rate it has to be pulled, right? So one can easily find that. It only takes about 0.1 seconds from the time the car hits the barrier until it stops. So what is the duration of the crash event is what is this? So as it hits the barrier and the entire event gets over, it's all in 0.1 second. That's what I was putting it as 120 milliseconds, but it is even lesser than that. Just 100 milliseconds, that entire event gets over, right? 100 milliseconds. So see this smallest duration event. As you can see, the front of the car is completely crushed after the test in this, right? This is good, as the car has to get crushed and collapse in order to absorb the kinetic energy and stop the car. So the entire kinetic energy, because of the speed of 35 miles per hour at the beginning of the event, has to be absorbed by the structure. That is what is an advantage of today's vehicles with the crumble zone. So we'll see them all in detail again. Right. So the same test before and after, you see that the front of the van is crushed up to the front wheels. So you can see this entire portion here, whatever is there, it has been crushed till this, and of course there is a displacement of this axle. And you see this here, complete cabin, and the rest of the vehicle is nothing happened to it. So you could see here. So what is the difference from here and here is there is no deployment of airbag. And you see here, this is completely deployed. Before the position is the complete deployment. And you see this after the hit, it's not thrown backward very far away. It's very closer to this. This distance is very minimal. So it's very closer to this. In this crash, the van is actually got just 23 inches shortened. So the vehicle is shortened by 23 inches. So that is what is this. It's not moved away from the barrier because it's crushed, it is appearing. if it is assuming that if it is fully elastic, it will go back and touch it. But fully elastic vehicle cannot absorb that energy, and there will be rebound energy. It is pulled and it will be thrown backward, and the same speed energy the occupant will be hitting. So what is this? Before test, the speed of hit is 35 miles per hour. Is the speed of the occupant as well. As it is being hit and the complete kinetic energy is absorbed from the frontal portion, you see that the energy transfer here is very minimum or neglected or not there at all. Not there at all, if I say that's what is called a perfect crash event, right? So you can see that a term perfect crash. So surviving a crash is all about kinetic energy, right? Because the vehicle is in motion, it is suddenly been stopped by barrier impact. So the event in 100 milliseconds completes. So there is a huge energy, high kinetic energy dissipation that has to take place. So that's what is the frontal portion of your vehicle in this particular test should take away by plastically deforming. That should not regain its shape. That has to go to a permanent deformation. That's what you have seen in the previous slide. When our body is moving at 35 miles per hour, it has a certain amount of kinetic energy. After the crash, when we come to a complete stop, we'll have zero kinetic energy. So complete stop, there should not be any energy. If any energy is there, that means that would make the experience by the dummy inside. So the occupant kinematics become very severe. Right. So what is that we were talking in our previous lectures is called crash pulse. The crash pulse should be zero at the end of the event. Right. There should not be any crash pulse as it hits that enter into a human occupant inside. So if at all it enters, that level should be very much below the tolerable level of decelerations of the human. That's what we were seeing in the previous classes. Also, we were talking on it, right? So to minimize the risk of injury, the kinetic energy should be removed as slowly. It's not suddenly, as slowly and evenly as possible. That's important. It should not be random. It goes like that. No, it should not be like that. So the deceleration should be slowly and evenly as possible. So the safety system in a car do this. So how this has been achieved? The vehicle crashes and that energy enters in case it's left with the crushing of vehicle enters the human, and that has to go with this. See, for perfect crash, there should not be any energy entering to the human occupant. So how that would be possible? The frontal portion crushes as slowly and evenly as possible, and that would be taken care by crumble zone. So crumble zone is another passive measure of safety in structural design of the frontal portion or the rear portion or the side pillar strength and so on, all to bring in the energy to be taken during the collision completely, and there should be zero crash pulse entering the human. There is no energy that goes to an occupant, right? So that's what is called a perfect crash. Ideally, you see the pre-tensioner and force limiters. So these are the part of your seat belts. Tightened up and the seat belts very soon after the car hits the barrier. But before the airbags deploys. So before the airbag deploys, what is that happening? Ideally, what is expected? Your seat belts, pre-tensioner and force limiters should be in act. And then the airbag deploys. The seat belt can then absorb some of the energy as we move forward towards the airbag. Milliseconds later, the force in the seat belt holder as back would start to hurt us. Holding us, seat back holding us back would start hurt us. So the force limiter at that time is activated, and making sure that force in the seat belt does not get too high. So the pre-tensioner and force limiter of the seat belt and simultaneous deployment of airbag is what is that is ensuring if at all any energy that is getting into an occupant and that occupant kinematics has been completely seized, completely arrested by means of seat belts and the airbag. So airbag is a soft bag that can take away this energy. It prevents hard hitting of head on a steering column. And it has to exactly deploy at the same time. So this crash test important purpose also is that are these passive restraints, seat belts and airbag are deployed at the right time. So how do you identify them? The acceleration and these test sensors data would reflect those functioning of them in an appropriate time, right? In case it is failed to deploy in the right time, you would see that from the acceleration history. You would see that seat belt is failing to provide the pre-tension and taking away the forces or limiting the forces from your load cell data. What is that force that are acting on different parts of body, or the motion sensor or movement sensor from the displacement of chest, how much it has been compressed. So that would all would reflect exactly whether these passive restraints are in appropriately designed and they act at the right time or not. That's why the full crash test with these restraints are conducted. Then the airbag deploys and absorbs some more of our forward motion while protecting us from hitting anything hard. So these events are described like this by statements is all because of the high speed camera images. I'm not having it put in this here. We will have that all again in detail to look at images, and that is how every event sequences can be appropriately understood. In this hypothetical crash, the safety systems in a car all work together to slow us down. If we did not wear seat belt, then the first stage of our protection is lost, and it is going to hurt a lot more when we slam into the airbag. So you see that there are statistics that because of wearing of seat belts and alone, there are many fatalities are prevented. The deaths are prevented. The airbag's action is what saved many lives. So if they are not appropriately designed or people do not use it, you see that such kind of severe situation, saving an occupant is a question mark. You can see that no any American, no, you can see that even they come to India, I could observe there are faculty from abroad. When they are getting into the vehicle, the first thing they do it is putting the seat belt. So they are so conscious. So everyone are following and understanding the importance of this safety restraint system. Maybe we are a bit lethargic. Okay, I'm just driving slow and so on. So, but in slow drive condition, if our unexpected event happens, and you see the severe hit is too much, right? And we do not know that, so we should be also educating ourselves in order to prevent our lives. So this is all something. One side we have all this thing, and we have to appreciate and understand, and we need to follow them to save our life during unprevented crashes. And future safety improvements, if you look at now itself, it is not achieved its final stage. It's a striving field, and people do make more and more restraint system. They make the passive restraint system more and more smarter. So that is what the smarter airbags and smarter seat belts. So that can the smarter airbag is that can sprout. That means that can deploy from just about everywhere inside the car. So what would happen? It would completely just to hold the occupant during the crash. So these airbags can deploy with the different speeds and pressures depending on the weight and seating position of the occupant and also on the intensity of the crash. So these data are all to be understood by the airbag, and then it has to do its job, and it does means it is very smart airbag. So such kind of technology employed airbag system, restraint systems are under research, and every year you see their improvement, and they come out with a advanced added safety features. Unfortunately, sometimes the deployment of airbag can cause serious injury and even death. So the deployment of airbag also can cause it. So the airbag application is very important, right, to the driver or passenger. The new technology, smarter airbag system, is designed because airbag in a car is the same. So I drive, or my kid is driving, or elderly person is driving. The drivers are of different age group, different gender, and different physique. So in such cases, what would happen? The same airbag may not be going to prevent. So one person can be prevented, but the same can cause injury to the other. So in such cases, the airbag should be smarter to understand who is sitting inside, what is the position of the occupant, and so on. So such kind of data, as soon as the driver or occupant inside the vehicle, should be transfer the data to be transferred to the airbag, so that it is ready to act at an appropriate time. So that is what is called a smarter airbag. Right? System is designed to reduce this possible risk and hence enhance the performance of the airbag itself. So just saying airbag is not sufficient. The airbag should be smarter, and that is what is still there are research going on in it. And similarly, smarter seat belts that can sense the weight and position of occupants and adjust the tension and maximum force accordingly. So technology is enabling car makers to design and manufacture safer, smarter vehicles, and consumers clearly endorse this trend as reflected by buying patterns. So the vehicle which has been more popular in market would stand now based on their safety measure. It may take wrinkling lot of cars and crash test dummies, but the information gained from automotive crash test means we and our loved ones may survive an automobile accident with little or no injury at all, right? So that's what is the feature safety improvements and no continuous safety improvement measures that go into automotive safety systems. So advanced frontal airbags, what we were talking, are employed in these vehicles certified by National Highway Traffic Safety Administration. They may be certified before 2004 or after 2004. And these data may not be till date data. I have got it from the site. And see that these are the vehicles which are certified with smarter airbags. So, car makers themselves crash many vehicles each year. Car manufacturers are required to certify that their cars meet the Federal Motor Vehicle Safety Standard. So, frontal barrier test is 208. These rules cover everything from how bright the turn signal bulbs must be to the crash testing requirement, right? So every small aspects are to be passed. The car makers have to be certain that if NHTSA goes to any dealer in the United States, why it's United States here? Because they are the one in the third era shown what does that could be done for safety. And there are many other developed countries and developing countries are also following the safety norms for their people. Buys any cars and crashes it at 30 miles per hour, the car will pass all FMVSS requirements. So all FMVSS requirement means it's not only 208 that what we were looking at today. There are many, and we will see them all in our course. To ensure that all of the different combinations of engine, transmission, accessories will pass, car makers might crash 60 to 100 vehicles themselves. So many vehicles they have to do crash tests so that they get the consistency of the worthiness of the vehicle. and so on. It is rare that a car fails the FMVSS requirements. So to challenge the car makers even more and to provide valuable information to consumers buying cars, the NHTSA started their new car assessment program, crashes cars at 35 miles per hour in both frontal and side impact, and rates the car based on how likely the occupants are to be injured during the crash. So this new car assessment program is what is resulted because of requirement of government act, and many countries are following that. In the last class we were looking at the slide, and again I have put it here again, maybe appropriate. And you see that our country is the 10th country in the globe to go for this assessment called the Bharat New Vehicle Safety Assessment Program. So I could see there is a group in our class has taken up this and then to go into more detail of this assessment program, right? So every country has got their own program. If you look at in USA, how NHTSA is there, the same way this IIHS is very, very important agency, Insurance Institute of Highway Safety. So they are giving all requirement standards and provision, because they need to have this. So this department is very important act because of accident claim and so on. So they have to have many, and this is like another parallel agency that do conduct and certify many of vehicle testing. So you have also an official website for this, and you get a lot of documentation, details of how these safety programs and vehicle testing and laboratory specifications all. So this course is something that we have a book where we read, it won't be sufficient. So it is that on an advanced course you have to connect what is happening today. So that's why most of the time I do go through the textbook, but that's very limited, and the information is to be abundantly required. So I visit these websites and then collect the data so that you can map our class with your textbook data and other thing. So that is what is the I do prepare for you all, right? So these are all the new car assessment program because of safety requirement. And you see that now the question is, what are my chances of being severely injured? So we know that our life will be saved. What are the chances that I get severely injured? If I ask, this is a pretty tough question. In order to answer it, we have to define serious injury. So we have to define what do you mean by serious injury. A lot of research has been done to classify injuries, right? Crash test researchers came up with a standard called abbreviated injury scale, AIS, for classifying different injuries. These same researchers published a manual that contains detailed descriptions of all the injuries normally found in car crashes. Each injury is assigned a rank. See, this is what is important. Rating, when you say, this is all important. Each injury is assigned a rank based on how severe it was. So based on the rank, we would be able to say how severe it is. So rank 1 is just minor cuts and brushes. So this is very rank 1 injury AIS index is there. That means it is not very severe. If it is rank 3, that indicates serious injury that requires immediate medical treatment and maybe life threatening. And if it is rank 6, then it is fatal, it's death. So the serious injury level is being ranked by 1, 3, 6 scales. So there are also called rating systems introduced by these agencies. So researchers have used crash test data to determine the likelihood of injuries that may be sustained in a crash. In addition, that data was used to create NHTSA star system. So they come out with the star system. So it's ranging from 5-star to single star. So the 5-star rating is an excellent vehicle, foolproof safety vehicle, they certify. So this system makes automobile safety rating easier for consumers to understand when buying a car. See that star rating means what? So in frontal crashes, the star rating is determined by the worst score on these three criterion. So what are the three criterion? One is head injury criterion. We have for that head sensor, accelerometer, chest deceleration. So we have a load cell in chest. We have movement sensor in cell chest, and then femur load. What is the load that come on the thighs, on the leg? So these are the three important criterion, and the worst score is what is deciding the star rating, right? See, the statement should be properly analyzed. The frontal crashes, the star rating is determined by worst score on these three criterion. So best score to worst score on these three criterion. These are the three criterions are used for star rating of frontal crashes. That means you have another criterion for side impact crashes. So for side impact crashes, there are two criterion: thoracic trauma index and lateral pelvic acceleration. So these are the two index. Right. So in order to receive a 5-star rating, so 5-star rating, if an automaker to receive all three for this frontal crashes criteria must be below the level that indicates a 10% chances of injury, severe injury. There is a star rating for each of this, each of the front seat passenger for each type of test that was run. Frontal or side impact. So in a side impact, you should have these two criterion, like the three criterions are this. So these are all important. You may be asked during quizzes or your exam. So your evaluation, all you have to go through critically the video lectures if required again, and the notes that I am circulating. So rating of frontal impact test. So the 5-star rating you can see here. So 5-star rating you want 10% or lower chance of serious injury. So serious injury is like this. So what should be the score? Rank should be 1. Rank 1, 3, 6 we have seen. So rank 1 says it's not serious injury. So like that you can say. And 4. So these are the percentage of chance of serious injury, right? So you have, so 46% are greater chances of serious injury in a vehicle there, then it is single star. So 5-star rating is what is very automakers to compete and attract customer they are working on. So these are the rating and the percentage of serious injury, chances of serious injury, right? It is chances of serious injury. So what do you mean by 10% or lower chance of serious injury? 100 vehicles are tested, only
Hello,
10
sir.
vehicles. Yeah, I'm just finishing in a few minutes, right? Then we will discuss. So on a few more slides, rating for side impact test. So if you look at here, side impact test, even 26% is the upper limit. So 5%, so it's become very stringent. So 5-star rating require the chance of serious injury should be lower than 5%, right? So these are some star rating program that go into it, and you see there are new app that comes out here. So there are revoking or callback of vehicle which are not safe. So such information to readily available. This Safecar app has been introduced. It can be downloaded in our mobile phone, and then we have to feed in these data of a vehicle. So whenever there is a recall or alert that from car manufacturer come, then you will be given an alert and you would be able to return your vehicle and get back. So such a kind of systems are there in US. And these are the regulatory requirement for crash testing. You can see the series. So what now currently we are seeing is this FMVS 208, and we have the remaining standards with these numbers. So windshield mounting, and there are side impact regulations, and then windshield zone intrusion. And this 301 is all for fuel tank. So there is a fire accident that would happen during crash. That's all because the fuel system integrity fails. So you have some standards there for frontal, left, rear, and side. So these are the other standards that we will also see in our course. And then this 300 series, 303, 305 is for an electric powered vehicle. So today's scenario of replacing our conventional vehicles by electric vehicles would be given by these standards, the requirements. And state of the art crash test lab, if you look at this photograph put on the slide, takes you virtually over there. You could see that, and the link below can be browsed through. So this Calspan's state of the art crash test lab is what is this view. And the capabilities are there in the slide. As I upload it, you can see that why these slides, these are important. You go for unique capabilities. So these are the requirement of any typical crash test environment. So you should go through this and remember them, and you talk on it. And what are the different types of tests that can be done in indoor? So these details are there. So this is one of the laboratory in US that execute any OEM's requirement crash testing in case they do not have. That's called Carlspan's Crash Test Lab. So that's it for today's lecture, that we have gone through details of full frontal barrier test, starting from dummy preparation, vehicle preparation, the understanding of events, and the sensors data, and so on till now. So with this lecture, I will finish now morning lecture. I will see that in the afternoon, more on side impact and the issues in it, right? So you have anything to ask now, you can ask, otherwise I'll end the lecture. Someone was asking in between. So what is your doubt? I could not see as I see my slide who is asking now. I could not immediately respond. So I hope if you have any doubts, you can ask. Otherwise, I'll end the lecture, stop recording. Is that fine?
Yes, sir.
Yeah.